Okay, let's sound check first. Eventually. Sound check first. Okay. All right. Welcome back to the DX12 streams. I'm sorry, I've been not doing very many of them lately. Just work is being work, and I don't necessarily want to program all weekend. But we're back. We're going to do some work today. Quick note, you'll probably, if you're watching this live, you'll notice that there is no more live chat. No one used it, except for Pornbot's last stream, and I don't want to bother with moderating, and I don't really have anybody to moderate for me, so I'm just leaving it off, and we can reevaluate that if at some point I actually get a ball in, which is unlikely. I don't want one. Okay, so what are we working on today? So the goal today is actually to convert all of our existing textures. So our existing textures and our existing texture bindings for render targets and such over to use the new system that we wrote last week. The first step of that is actually going to be writing this swapchain abstraction that we've been putting off for a while, almost a month, according to this, because we need, if we want to move all of our render target code over to the new system, then we need some more concise way of getting RTVs for the swapchain, and that should preferably be internal into the GPU layer rather than something the high-level renderer has to care about. So while we're at it, we're also going to handle swapchain resizing, which is, to resize the window, you got to resize the swapchain, or else it's not going to match. I'm not actually certain what Windows behavior is here. I think if you resize the window but don't resize the swapchain, then what happens is either you get a subrect of your window filled, so everything outside of the swapchain dimensions is empty, or it stretches. I'm not sure which it does. I'm pretty sure it doesn't crash. Pretty sure that's a console thing sometimes, but not a PC thing. So we'll handle that. That's going to be a little bit awkward because we're going to have to handle some. We're going to have to do some global data management because the notifications that you get that, hey, the window is resizing, come in. I think they come into the window proc, and window proc doesn't have a context pointer, so the only way window proc can talk to the rest of the program is using like statics. So what we're doing for this quit handling right now. So that's, it should be fine. I don't think this project will ever have more than one window. If you ever do need more than one window, you can do some tricks with, you put the global data in thread local memory, and you can put each window on its own thread, so it has its own thread local memory, and then handle it that way. That's kind of ugly, and having window proc on a different thread than your renderer is also just kind of messy as well. We do that for Viper. Our window runs on the input thread and the renderer runs on the out thread, and we get all sorts of weird things where like a swap chain resize will come through twice, because we'll see the width change and then we'll see the height change as two separate things, and so we end up resizing the swap chain twice, which is not great because both of those is await for idle, but it's fine. We shipped it. So, we don't have to deal with any of that right now. We're just going to put things at the global scope. So, what I want right now is, let's okay, that's interesting. I forgot that when proc returns an integer, like this is actually wrong. We should not be returning true here. We should be returning 0. Actually, not sure what behavior is returning non-zero here. don't know. So we want to handle WM size message. So static. I believe it's a event32 instead of event16 because alignment reasons. Start at 1280. So we probably want to handle this in the long term because we want to handle when you maximize the window, you probably want to switch over to either exclusive or borderless full screen. Just because that like full screening, but with the window Chrome is kind of ugly. It messes up your aspect ratio, and it also does things to the compositor that you would rather avoid for performance. Like if you are in full screen, I think even in like borderless full screen, you on modern Windows you bypass the Windows compositor, which lets you it bypasses Windows vsync, and it basically removes an entire copy step at the end of your frame, which means that you can render a little bit faster. It's not a huge difference. Being able to turn off vsync and like have it actually off GPU side is a big difference, because you can't really do that in window mode because the operating system compositor is vsynced, and so you will you can be not vsynced, but like you keep your process not vsynced and it will run CPU side as fast as it can, but like the compositor will just drop entire frames on the floor instead of pairing, which is, I don't know, you could view it as good or bad, but it's a thing. But we're not going to handle these right now because by virtue of streaming, I don't really want to go into full screen because I'm not sure I'm not sure how well OBS will handle that if we're no longer going through the compositor. I assume it handles this fine. And it's probably easier for it to handle with DX12 than it is with Vulkan. I know that at some point I had some issues with Knockout City, like internal builds of it, like not being captured by OBS when they're full screen because we bypass the compositor and nothing captures it correctly. I don't remember the details, but in any case, we're not going to go full screen streams. So we will try 0 here. Call that good. So we're not actually going to trigger a resize here. What we're going to do each frame is basically tell the swap chain how big the window is, and then it can make a decision on whether it wants to resize. Maybe. Actually, one second, but that may not be what we want to do, because so we have resize buffers. I don't know. Yeah. So, they may actually have this be driven at the high level. The reason is that in order to resize the swap chain, you have to be done with all of the work that writes to the swap chain, or reads from it, or whatever. Which means you basically have to wait for GPU idle, or it's queue idle, or any queues that write to the swap chain. So that's at least a 3-frame stall, and then you resize all your targets and move forward. It also invalidates all the views that you have to go through and destroy all the views that are used for that swap chain before you can resize it. So we need some handling internally, I think. Well, we need some handling somewhere to make sure that you will never have a stale view to a swap chain buffer. So like if you have a render pass that renders directly to the swap chain, probably if like the existing thing does this, and in a full image render you would probably have some full screen triangle pass that relates to the swap chain, or maybe a compute shader version of that. Like whatever render target view or unordered access view is used for that swap chain needs to be destroyed. Swap chain then needs to be resized, and then you create new views. So I think internally, like when we create a swapchain, we're going to ask it for some kind of view, and it's going to create those internally, and then we're going to like ask for those references to ask for the references to the views when we need them. So like high level code never owns a view to a swapchain. Is the way I want to handle this, because then we can do the tracking internally of like if we always treat it as a transient reference that's returned, then we can ensure that no high-level code ends up holding a reference to the swapchain resize fails, and we get issues. Or worse, the resize succeeds somehow, and we have a garbage descriptor pointing at nothing. So let's go over to GPU header. We will have construct GPU swapchain t. All right. So we'll use our texture struct for these, just because it'll make the getting the views out of it easier. And then we want we will store usage flags. This will tell us, do I create a UAV? Do I create a SRV or RTV for this swapchain? Because pretty much all of them are useful, except for, I guess, depth stencil view. I think you're allowed to bind the swapchain as an SRV, so it is kind of weird. But you can use that for things like screenshots where you read back from the presented swapchain and write to some other texture that you can upload. So I think right now we have descriptor handles for these. So we'll have these. And we'll just add static arrays of these because it'll make the code cleaner, but not that big, right? How big are you? Yeah, you're like 8 bytes. Who cares? Usage flags. These are actually going to be duplicated down in the texture config, but it's fine. Having it promoted up here makes it cheaper to go and check which of these we're allowed to create. All right, so let's remind ourselves what a swapchain create actually needs. Bit type format. Buffer count. It's always going to be 3 for us, I think. Yeah, we also have this usage that we have to pass into the swapchain. Tell it which of those fields we're going to use. The swapchain for hblend, we need to pass in window. Some weird handling here for full screen that we're not going to bother with. But I think overall, this is what we want. So, does it need a queue? I don't remember. Yes, it needs the queue. So we need a queue, window, swapchain description, which we'll create internally, but like we need format and width and height. So here's swapchain T. See. For now, we're going to just say that we always create the same format for swapchain. It's not entirely wrong. I think one of the things that you can do is the more correct version of this is you do some queries to figure out what swapchain format the device wants, because different devices want different swapchain things. Like Windows has this thing from ages ago where all of its back buffers are BGR instead of RGB, which is interesting. But these days, the compositor will usually handle the conversion for you if you don't want to use their fancy format. The other place where this comes up a lot is if you want to output HDR, you have to use HDR-capable formats like R11, G11, B10, or it's 1010, 10.2 is also a common thing. And there's some recent stuff with like RGB 9 exponent 3, which is this utterly bizarre format, but it handles really high saturation better than other packed 32-bit formats, but it's not actually renderable in a lot of APIs, which is a shame. Anyway, we're not going to do HDR just because I want to make sure that we can do HDR when it comes up, but it's I want to make sure that the return number can be scaled up for HDR and whatever. But doing the actual work for HDR doesn't seem all that appealing to me. I don't even know if this. I have no idea if my laptop monitor can even support HDR. And so on. The API level stuff for that is kind of boring. So we need a swapchain create, swapchain resize. Which, assuming that the resize, it's pretty much the same things. No, it doesn't. Interesting. You can't turn allow terrain on the resize. We built the swapchain from scratch. So that's interesting. Okay, we're gonna say that resize takes all the same things. It may not use them, but but you could imagine a version of swapchain resize which tears down and recreates the swapchain from scratch. I would assume there are reasons you would want to do that. I mean, I guess if you want to turn terrain on, then you have to. So if you want to turn, I guess that gets you you could do this plus vsync, and it could get you the adaptive sync, where you'll stay vsynced unless you miss, and then you can tear. I'm not sure. In any case, we're going to I assume it's faster to resize versus recreate the swapchain from scratch. But we'll leave our options open. So then we want a GPU swapchain get RTV. We'll get the RTV for a specific frame. The reason we want to do this rather than just like, hey, give me the current frame, is you know, just imagine you want to read from the frame you just rendered. So like maybe you're injecting a screenshot pass after your present that reads back from the swapchain and writes out. You wouldn't do an FPV for that, but you would do like current frame -1, which would get you the frame, like the previous frame's swapchain RTV or whatever. I don't know if we're actually going to use this flexibility, but it's not hard to have. So it would be nice to just have it. My inability to type strikes again. I think these might actually get renamed later to be, you know, use the acronyms, because writing out render target view everywhere is going to get tiring pretty quickly. All right, so I think this is all the functionality we really need right now. No, it isn't. We need to read swapchain destroy. That one's kind of important. So like with this, you could actually do a inefficient version of resizing, where you just destroy the swapchain and then create again. But we'll try to do it properly. This is right after the queue stuff. We'll try to keep things in order. All right, so swapchain create. Always use that. We need so here are the three that we want. We want render target output, shader input, and unordered access, depending on what usage flags are passed in. So we'll have here's the type here. Just do here because they're just flags. RTV research is that. These are combinations. Let's actually formalize this more. RTV, UAB. Then we also handle SRV. All right. Oh, right. Yeah. I knew I forgot to put something in the swapchain structure, and it's the swapchain. Oops. All right, so GPU swapchain. Okay. So, depending on the usage mix, we're going to go through and create the various views. So we're going to do this really inefficiently because I don't care about speed here. At this point, we've already waited for idle. So, or like, create happens once per run, usually, but like resizing will do the same thing. So this actually probably gets pulled out into a larger function. But create happens once, resize will be after a wait for idle. So performance is not really what you care about here because you're gonna hitch because you have to identify. So who cares if you hitch more? But the reason I'm doing this is so we can get buffer this way. This is interesting because this is something worth talking about. In 99% of cases, the way that you get a D3 D12 resource is you create it. So that's true for render targets, depth buffers, UIDs, whatever, all of your asset textures. You create the resource and you can upload to it or render to it or whatever. That's not the case with swap chains, and I think swap chains are the only time where this isn't the case. So swap chains, you create the swap chain and then you have to ask it for its buffers, which means that like our model so far has been you create a texture to use a render target or whatever, and you actually go through and create the resource. But in this case, we have this resource that's already created for us, and now we want to wrap it in a texture. So I'm trying to decide whether I should put this in a function. Because really what we need is we need the texture config, because textures are the resource pointer and config. So if there were going to be other cases where we would get a resource pointer and we would either wrap it in a GPU texture, I would write a function for that. But only places I can see this happening are swapchain, and maybe if we used some third-party rendering code. So it's usually use like API types as the sort of format for arguments and stuff. But I don't think we're going to do that on the stream. We might. There are some cool things that we could integrate, but I don't know. I'm very much a not invented here kind of person. I don't much like integrating third-party code, mostly because then you have like an entire chunk of your frame you may not understand very well. Like for Viper, pretty much the only thing that we integrated externally was FXAA, and I actually went in and dug around in it a bit, trying to make things faster. So, yeah. I would never really feel comfortable with something like, oh, NVIDIA wants to come in and like put a prototype effect in your frame for you, and they'll write it for you, and then they'll leave and you don't understand any of your code. So, not a huge fan. Anyway. So I think we just will create our texture config here in line. Place. So result textures. Back buffer is always going to be a texture 2D. I'm pretty sure. Yeah, I guess you could. I don't know if you can create an array texture as back buffer, but it doesn't really matter. That is okay. So create our own texture thing around this, and Right. These are. I don't love this. I don't really like swapchain creating textures because then we have two ways to create textures. That's not awesome, but it's fine. No matter what we do, swapchains are going to be a little weird in how they interact with everything else. So we'll do a simple thing, which is just somewhat weird. All right. And then now we can just create these. That's the work we did last stream. This is relatively straightforward. Right, I never broke the UAV path. We don't need it right now, so we're just not going to implement it at the moment. When we need it, we'll hit this assert and we'll go and do the work. I just don't want to get any more distracted than I already am. Okay. I think the other thing I'm going to do is I'm going to copy off width and height here. The reason I'm going to do this is we want high-level code to control the resize. It's kind of going back on what I said earlier, but high-level code needs to control the resize, like when resize happens, because you resize your swap chain. Well, you may have a whole chain of render targets that are upstream in your frame from swap chain, and they probably want to be resized at the same time. So it's nice if high-level code detects that, and then it can go through and resize all of the relevant render targets at the same time, which means that one, it means you never really render incorrect things where like the swap chain's one size and your render targets are another size. The other thing is that it means you can get away with a single wait for idle rather than and wait for idles depending on how you discover that you need to resize render targets. So it's nice for higher level code to own that. And so I don't want it to have to chase down through a GPU texture T pointer within the swap chain to go figure out what size the swap chain is. Because we're going to have to do this check every frame to see whether we resized or not. So it's a little redundant, but it'll make things simpler. Well, it will make things easier, not necessarily simpler. Okay. So that should be all of that. Swap chain destroy is going to make this null safe. So I want to go back and like actually make all of our destroy functions null safe, because that's one of the most annoying crashes to run into, is like your app dies halfway through initialization and then your destroy functions crash because they're trying to free things that were never allocated. So just like, so your high level code ends up with tons of this all over the place, which is just kind of obnoxious. So putting that down in the destroy functions makes sense, because then resource destruction is almost never a hot path. If destroying resources is your hot path, then you're probably doing something wrong. It does come up a bit with like, oh hey, you're unloading a level's worth of textures and model data, but even then, it doesn't make a huge amount of sense to be all that concerned about a few branches. Yes, I know I'm rambling. Always rambling. So do descriptors need to be destroyed? I don't actually know this. Presumably not, because we're not actually like, we don't tell the device that we're allocating this. So I think we can get away with just like probably memset the handles just to be on the safe side. think this is correct. Well, it's not totally correct because this isn't actually reading the texture. I need to audit all of my destroys to make sure that they actually destroy things correctly. So we'll call texture destroy. That's just going to call release on the resource pointer, which I think we need to do so that the backend can destroy the actual resources. Like actually free the memory out from underneath of it, because otherwise yeah, otherwise we'll leave ref counts alive to the swapchain buffers, which will prevent us from actually destroying the swapchain. That's actually going to come up with resize as well, because we're going to have to actually destroy the, all of our references to the buffers before we can safely resize the swapchain, because that's going to create new resources under the hood. So that's important. All that out. I'm actually going to zero out the other stuff, I think. So that won't save us from cases where like high-level code takes the RTV pointer that it gets and runs with it. So like that's, I have no access to that here, so I can't. I can't have destroying the swapchain like trigger asserts if somebody takes a view to this swapchain and leaves it. Actually, we do create views. So do we? It doesn't hand us anything that we can release. So I assume this is all they really need to do. Okay. Moving on, let's do resize. Should go pull this part out into a helper function so that we can do it in two places. Sure, we have to put them height on the swapchain itself. Okay. You know what I forgot? The swapchain. Kind of important in swapchain functions, you know. Go back onto this. Means I need to go update this. All right. So again, we're going to go through and destroy textures before we resize. also going to make waiting for idle is, I think this is sort of a convention we've kept in general, is wait for idle is the high-level code's responsibility. So we're not going to wait for idle on swapchain resize. We will assume that the high-level code has already idled the GPU, or at least the queue that is associated with the swapchain. Because we have to go through and destroy all the textures. This will this won't actually destroy the textures, I'm pretty sure. All it will do is remove the references that we hold to them, which I think we have to do before it'll actually let us resize. So we can do swapchain resize buffers. It's constant width, height, format. Right, we need to know the format. I'm going to put format on swapchain as well. Flags. Right. Using this and create. Wait, why isn't this in create? It is, we just don't use it. Okay. Then I think we will continue to not use any flags. Press 0. Okay, swapchain needs to remember its format because I don't want to have to dig into the texture configs when we have questions about just like the high level, what kind of swapchain do we have. Most of the point of actually filling out the texture configs is just so that the different resource views have that information where they expect it. But all of this is common across all of the textures in the swapchain, so it doesn't make a whole lot of sense to have it be sort of I lost my train of thought. In any case, like we want to have the common stuff that we actually care about often and then promote it up to the high-level structure because because fewer pointers to chase is always better. That also means that this helper function no longer needs fixed format, because it can read it off the swapchain. So that's cool. Resource function. There we go. So I assume this returns an H result. Yes, it does. All right. So now we need to call our helper again to go through and create all of the views we need again, our texture structures and all of that. So that's resize. In the interest of time, we're going to leave these two unimplemented for now. I mean, it's not going to be very hard to implement, but right. In order to translate this to a particular buffer, we need to be able to speak to the queue. Swapchain can only be used for one queue. So, well, is that true? That may not be true. I think you may actually be able to use the swapchain that is shared, but we're not going to do it. For us, only one queue can use a swapchain. So we're going to keep a reference to that around. Because if we do that, then we can use that queue pointer to compute our frame modulus frame count. So this should let us get the correct RT. We will return swapchain these. And just for safety's sake, we will assert that swapchain was created with usage expecting to generate RTBs. So, I mean, to a certain extent, if the high-level code creates the swap chain without telling us we want RTBs and then tries to query for RTBs anyway, they kind of get what they deserve. But it's always nice to have. It's nice to have that assert be a assert rather than going and just reading garbage somewhere. This will actually break because we're not creating UIDs, but it's fine. Sorry. Okay. Got a bunch of compiler errors to deal with. Let's see. We don't have Q at this point, so I'll move this down. So we want to keep usage flags because one of the things that you can do is you can, we could do something where if you change the usage flags, we go in and actually destroy the swap chain and create it with the new usage flags instead of just resizing the existing thing. Because that could be useful. Like say that you've got a game and you want to be able to do something like overlapping your post-processing with rendering of the next frame. So the way that you would do that is you would put the swap chain on the compute queue, and there are vendor extensions that will let you write to the swap chain as a UAV from a compute shader, and then trigger present from your async compute queue. And then you can have like all the processing happening while you're rendering like shadows and gbuffer for next frame underneath. We might do that at some point, but whatever. And the point I'm making is that doing that is not something that is universally supported. So you could have like your default path is, you know, just everything on the graphics queue, and you write the swap chain with a fragment shader or whatever, right? And then call present on the graphics queue. And maybe you have an alternative version of things that users can turn on in the settings menu, or you turn on when you just detect that you have this extension available or whatever, where you do compute shader presentation and present from compute queue. Because that changes the usage flags of your buffer, I don't believe you would be able to handle that with just resizing. I think that would require that you destroy the existing swap chain and create a new one. So we could have this function be able to adapt to that case where if you've done something that can't be handled with the resize, then we take the slow path and destroy and recreate the swap chain from scratch. So as it stands, we would not be able to just call the existing swap chain create again. Maybe we would want to refactor how create works so that we could share the code for the recreate path. But in any case, that's a bit more complicated than what we want to do right now. So we're not going to. Same story for window. Oh, that's wrong. As annoying as the unreferenced parameter warnings are, they do catch some really stupid bugs for me. So I leave them on. I'm not using any of this code, so it should still run. Seems like it did. Okay. So now, we are getting closer, I promise. We're going to create our swap chain. This way, which is nice. This all goes away. and we'll get rid of that buffer stuff in a moment. So what we will do here is in this case, we have detected that a resize has happened, and we need to resize our swap chain. So that's not the function. So the part is now swap chain, swap chain, right. Uh, well, so Okay, is that everything? That is not everything. That's expected, I guess. Oh. What? Oh. Oops. Okay. Interesting. That is not what I expected. No resize crashed. Okay, so it crashed because I'm dumb and forgot to wait for idle. We're talking about how wait for idle is high level responsibility. Context and graphics here, I believe. Just here. So WFI before we resize, which should make that better. Um, so this is going to continue being a problem because we have to have our depth texture be the same size as the color textures in order to bind them together. But if we don't resize, then it shouldn't be an issue, right? Yeah, it seems to be fine. I don't understand why this is happening. That would do it. Okay. There's no issues here. Now on the resize, it will fail. And why does it fail? It's not actually where I expected it to fail. interesting is that I'm trying to well, there's two issues. One is render view is not compatible with depth view. So presumably trying to render after set render targets fails in that way is a device removed. And that's why we are proceeding to hit this error access denied because, or like this actually blocks access to that render target view, and then we lose the device when we try to write to it anyway. Okay, so we have, oh, we do have swap chains that resize now, which is cool. But I don't know, maybe if I turn off the depth buffer, if I get this to run. Well, let's move our depth buffer over to this, over to our new GPU texture system. And let's see if resizing this appropriately is enough. I don't remember, are we actually using clear values for these? That's kind of important for textures, or for depth buffers. Apparently we were not. So say if we are at depth stencil view, set a faster value. Just to be on the safe side, we're actually going to pass null, because I don't think null and zero initialized are the same for clear values. Longer term, we probably want best code value for stuff like the lighting buffer, but actually not the lighting buffer, because we're going to write to that from as a UID. Probably gbuffer needs this. Anything that you're going to rasterize to, but you're not actually going to write to from like compute, you want to give it a fast clear value. Things that are written from compute tend to, like the driver will just not compress them if you do that. So there's not a lot of point in providing, fast color clear for, your lighting buffer, and then you write to it from a UAV. And well, as far as the driver is concerned, then you just can't do a fast clear of that. So that's when you fall back to, if you call clear on that buffer, then it will, you'll get a pixel shader clear, which is not the worst thing in the world, but it is pretty slow. Anyway, the depth buffers definitely want to provide a clear value, because those are pretty consistently compressed. And it'll make your clears faster, and it'll make your reads fast. Well, it'll make your depth test faster, but it won't make any of the, like, if you bind this to a shader, then it starts being compressed. Once again, I am rambling. Are you sick of it yet? Okay. So what we will do here is we will have our depth buffer config. All of that can go now. So these two in the right order. Depth stencil only. Longer term, this is probably depth stencil and SRV, because you want to be able to like, after your gbuffer rendering, like, you need the depth buffer in order to reconstruct positions for lighting. So we will eventually need SRV support here, but not right now. Let's see. Yep. Let's see. Right, we need actually some format. To float. So do a texture. So that's that. Handle that. Okay. So the whole reason we did that, I mean, aside from making things nice in general, is now we can recreate the depth buffer in the swap chain resizes. So destroy depth texture, then we also need to update the DSV here. That actually suggests a problem we're going to run into, which is seems like we don't actually have to destroy the various resource views when we're done with them. Like, there's no D3D12 resource that we have to call release on. But right now we don't have any concept of returning descriptors to our storage heaps. So every time we resize, we will create a new depth stencil view. And that will take a descriptor out of the DSV heap. And we're not going to be reusing that ever. So that's not fantastic. It means that, like, you know, I sit here and resize up and down and up and down and up and down. Eventually we will exhaust the probably the DSV heap first. We'll have to create 3 RTVs each time, so maybe the RTV heap first. One of them will exhaust first, and then we will crash, presumably, because we won't have any descriptors we can use. So that kind of sucks. So there are a couple of ways that we can handle this. One is we sort of stick our fingers in our ears and ignore that it's going to be a problem. The other is we can keep track, we can have a destroyed f-stencil view thing, and we keep track of what descriptors have been freed. So that next time we go to allocate one, we check first, hey, is there something in the free list that we can use? And if not, then we go and allocate one from the top. Or we can make that code simpler by just like putting everything in the free list when you create a heap, and then everything allocates from the free list. That would be a way to make it work. The easy way to do that is with a vector, but that's a surprising amount of memory to keep around. So, like, we would need to do this for all of our heaps. So, say, I think we have like 3096 descriptors in our main. Here's where all of our SRPs and stuff live. Like, I think we have 4K descriptors in there. Times 8 bytes per descriptor. That's 32K of storage for a free list that just has the descriptors in the free list. So that's not awesome. So 32K isn't the worst possible thing, but it is, you know, there's your entire L1 cache on a lot of PCs. I guess that might not be true these days. I think L1 might be 64K for a lot of newer chips. In any case, it's either all of or a significant chunk of your L1 cache, which kind of sucks. And it's just really low information density because they're all like, you know, the base pointer for all of these. You don't need 8 bytes for a list of roughly sequential integers. So the more correct way to handle this is when you create your heap, you create a bit vector that is as long as your heap. So essentially you'd have 4096 descriptors. We would need 4096 bits, which assuming we use, we'll probably use D words for reasons. So that's a kilobyte. What's wrong? That's 128 bytes, which is much more palatable. And then when you go to allocate, you check for what's the first free bit in this array of bits. And then when you go to free, you check for, like you just set the corresponding bit. You check that the bit is valid, which could be important. That sort of requires that we keep some metadata around about in the descriptor itself. So like our descriptors stop being D3D types and become a struct that wraps the D3D type and like the bit index inside the heap that we created it with. So that's a thing. Let's see. Started around 3:30, so we're about 2 hours in. We might go and do this. First, let's check and see if resizing the first we'll check that like resizing this here is enough to get rid of that cert we were seeing. That is not the case. God damn it, I did it again. So this is supposed to be indefinite. Stop fighting me on style, Visual Studio. Okay, did I do that anywhere else? It's... Okay. Right. Right, so our transitions are now wrong, which is unfortunate. And we still lose device here. Right. Okay. Okay, so this was not what I was expecting it to be. So the problem we have is a swap chain has n buffers. In our case, it has 3. Um, and so when you call present, it will read from buffers in sequence. And so all of our code has to deal with the fact that, like, okay, what frame am I on? Am I on the frame for buffer 0 or buffer 1 or buffer 2? So when we create the buffer at startup, and we're just using that, we when we create the swap chain once at startup, our swap chain present count and our frame counter are the same. Like, they're in lockstep. But when we resize, we may be anywhere within that cycle when we hit our resize. And the problem is that, say our next buffer was going, like our next present was supposed to be buffer 1, but we trigger a resize. So now that the swap chain has been resized, it's expecting us to render to buffer 0. But external code figures out what buffer to render to based on the global frame counter from the queue, which is currently set to one, or like it mods to 1, right? So we're binding the wrong buffer for our back buffer render target compared to the buffer that we were supposed to. So I think this is fixable without a whole lot of effort. So what we're going to do is, like, we already have the queue provided when we create the swap chain. So what we're going to do is we're going to record, move this up so the line's better. We are going to record the last frame that we resized. And so when we want to get a buffer out, we can subtract off, so we can take our incoming frame, which is like locally relative, and then subtract off the last time that we resized the swap chain, and then that's the number of presents since we resized. And that number, mod 3, will give us the actual, the correct index into our textures for the swap chain. I think that will be correct. So let's try it. So encounter primary styles do the same thing. Hey, we have our queue around for this. So there's a problem that's going to come up right here, which is, let's say we just resized on this frame, and we ask for a like an SRV for the previous frame swap chain. Well, we can't provide that at that point, right? Because that previous frame's buffer no longer exists. Like, it gets destroyed as part of resizing the swap chain. So I am mildly tempted to get rid of this arbitrary frame thing here, but for now we're going to add an assert that frame greater than or equal to swap chain master size frame. So we'll just crash loudly if you do that. Because that gives us the capability of frame minus our last resize frame that should give us the correct relative index to the swap chain. Let's give this a shot. All right, maybe not. Is there a way to, like, can we just tell it which buffer to give it? So that would make things simpler. No, of course not. Flip discard. Um, checking recess. Yes, it failed. Yeah, we're checking recess. Okay, so if we were failing in resizing, um, then we would hear about it. Um, so I don't think this is the case if we just have some references hanging around. I'm really not sure. Um, it kind of sounds like I have the concept of how swapchains work wrong. Well, I'm like it always presents to 0 or something. That feels like we would have run into issues prior to this, though. Like, I think flip discard lets you access all 3 buffers. Only the if we run don't resize the window, like we get this warning because we're not creating the depth buffer in the correct resource state. But we don't get any issues with relating to the wrong buffer. That only happens after we resize. Which seems really weird to me. I don't know if we were like unintentionally changing the swap behavior when we resize. So what's really awkward is that, it tells us that for swap effect discard, we can only access the 0 index. Where in sequential or flip sequential, we can access all of them, but only the 0 can be written to. It doesn't tell us what flip discard does. So right now we're going to be, like, prior to resize, we are rendering to the wrong, I mean, assuming that flip discard also only lets you write to the 0 buffer, we're doing the wrong thing here. Like, we're going to get a variety of buffers, I assume. Let's just drop a breakpoint in here and see. Yeah, so here we're accessing frame 2, and frame 0, 1, 2, 2, 1, 2. And that seems to be fine. But as soon as we resize, oh. Well, that's really fucking weird. What? How did we make that happen? Maybe we should do this after the begin frame. Try this. Yeah, no, do get doubled up. That's really weird. Okay, let's go and fix this. This level 1, so we can get it out of the way. State just this is not the correct thing to do. The correct thing to do would be to have the user tell us what initial state they want, but we should just do that. Yeah, so all that's left is that we are somehow oh, right. Yes. Because we're still indexing the resource for the barrier incorrectly. So that's So we will do the same trick here. I think we did the right thing, we just didn't do it enough. Never finally a mistake. Maybe this should, in the future, return the actual GPU texture key instead of the raw resource pointer. But for now, let's do it. So awesome. We no longer need this at the high level. So that's cool. Almost. Great. So that is the problem that I was talking about earlier. We were resizing in a loop because we weren't updating the width and height, and so we ran out of off the end of the heap and crashed. Now it works. Awesome. So that's really cool. Let's see. Show you a question. Is my audio still working? Seems like it. Okay, good. I had some issues earlier this weekend with my headset. Is apparently battery powered and it ran out of battery and stopped functioning, which would be kind of unfortunate if it happened in the middle of a stream. Okay, so now we have upper back buffer handling. We can resize and do, weird things. We would like to update our camera uniforms as we do this resize, but we actually haven't. We actually did the incorrect thing for for our uniform buffer handling. So we can't really update uniforms per frame, which is what we would want to do. I guess we can use the wait for idle as just like, here's your opportunity to go stop the that old matrix in the buffer, and we could get away with it. But realistically, what we want to do is we want to be able to upload different uniforms per frame. And at current, we can't because our buffers are single buffered. Like there's no, you need to be like triple buffered in order to handle, hey, I want to upload different contents to this buffer each frame. We don't want to handle that in the back end. We want to handle that the top level, and so it's just a bunch of stuff that we'll have to deal with to do that. But for the moment, we're going to just let the aspect ratio be a little weird when we resize. It'll be fine. Okay. So I'm up on 3 hours here. I would we have moved this over, so that's cool. We've hit both of our goals today for the first time. Day 2 hit all of its goals. All right. So I would like to do the whole bit vector thing for descriptor heaps. That's going to be a fairly significant refactor. Because we have a bunch of places that are using the raw descriptor handle, so we'll need to not do that. Well, we can sketch out what that would look like, but I don't think that we're going to actually do the work today. So this also lets us like have to store off the CPU and GPU handles together rather than having to like refigure out what the GPU handle should be. So how do we actually handle that? So now there were a few cases where we had to care about GPU handles. Yeah, find descriptor puts things in the. Well, yes, it's only when we are actually binding the descriptors that we care about the GPU handle. So we can probably get away without not being a thing. So this one we probably 16 bytes. Let's actually put heap index down here, and maybe it'll be 12. And so all of these handles are going to contain their index in the heap and the CPU handle. So we can then free the entry in the heap by figuring out the bit to set in our GPU heap. In our descriptor heap structure, we will keep a bit vector, and we will use probably 1 for allocated and 0 for unallocated. And then this just needs to go through and clear the appropriate bit to free it. We can do fairly quick checks for, find the first bit in this integer is relatively straightforward to do. Single instruction on most CPUs. Everywhere that uses CPU descriptor handle will need to use GPU descriptor handle, which means that this probably needs to move up. It doesn't have any dependencies on anything, so let's just put it at the top. So we'll have this vector of UN64. I think I mentioned using keyword size before. I think you have 64-bit time per set, whatever, for yeah, I think that's common enough now. You can implement it either way. It's just twice as many instructions for a certain number of bits if you do the 32-bit version. So we would allocate this with as many bits as we need, round it up to like a 64, and then set and free them as needed. So, you know what? Let's go ahead and give this a shot. Feeling like doing it, so we're going to go ahead and do it while I have the motivation. using the raw handles. We want to change how this works long term anyway. We want it to be like in terms of predefined, like having structures that represent like here's a descriptor table, here's binds for the descriptor table. Because we're going to need to have like data-driven building of root signatures, and just having table-based bindings will make things cleaner, hopefully, and that'll get rid of, like, pretty much this function will go away, but we'll get there eventually. So fix all places here. Either simple don't know why that's in there. No, I copied it by mistake. Allocate, handle this for us. Okay, So heap allocator is going to do this for us. And then it should be straightforward to change the rest of the code to work with this. What does the view handle? Stop. Okay. So now we track the heap index through all of these. So now, let's see. And we create a descriptor heap. To round up to 64 bits and sort of gross, sort of reserving and then setting the length to the amount reserved so that we can actually without actually going through and pushing items one by one. So that's it. You know, we gotta mem set it anyway. So, So the one caveat about this case is our bit vector tracks multiples of 64 bits. So if you pass in a capacity that is less than 64, we have tracking for bits that cannot actually be used because they are not valid. So you have a couple different ways you can handle this. One is you can just round up your capacity to multiple 64 no matter what. And you can probably get away with that for descriptor heaps. But if you want to apply this sort of bit allocator pattern more generally, you can't really do that. So what we're going to do is we're going to have to, when we do the actual allocate, we're going to have to check that we're going to scan the array of bits looking for one that is free, so like a 0 bit somewhere in there. The bits at the end that are off the end of the buffer will always be 0. So we need to we can handle this two ways. One is at initialization time, we can just set all of those bits that are invalid. And the other way is we can just, in our allocate function, check, did we exceed the unaligned capacity of this heap? I actually kind of like the idea of making this, like, just setting those bits as like always allocated. So if we were in this case, what that's going to mean is basically our last word has some number of bits set on it. So take the total number of bits that we have, which is our word count times 64, minus subtract off the capacity, which is unaligned, and then we'll get some value that is 1 to 63 here. That will tell us how many bits we need. So we're going to clear the most significant bits, or like we're going to set the most significant bits. So it's actually easier to set the least significant bits. So what we're going to do is get the valid bit count, which is 64 minus the invalid. bit count. And then I'm going to compute the valid mask, which is 1 shift up by times 1, so we get the mask. Are you unhappy? So this is the mask of valid bits, but we want the mask of invalid bits, which is just the ones complement of this. So we get the last word, and we'll set it to the ones complement of valid mask. And so if we have a capacity that's not a multiple of 64, which I don't actually know if we're going to have this case. We don't currently. We can force it to happen just to test that we get this right. So right there. So the count is 32, which also means that our valid count is going to be 32. So our valid mask, let's look at this in hex because it'll be clearer. So our valid mask takes the low 32 bits and sets them on, but we want the high 32 bits. So we do invert valid mask and okay. This is actually correct. It doesn't look correct because it's not a monospace font, and so it looks like there are fewer set bits than there are unset bits, but they are the same. And so we stuff that into the last word. So everything up to that word is going to be just zeros because all of those are valid and things you can allocate, but invalid things are beyond that range. The one thing that we will have to check during free is making sure that we don't unallocate one of these invalid bits. Like we should free one of these invalid bits because now because if you do that, then you're just saying, okay, this is something that the allocator is allowed to grab, and that would be bad. So we can change the allocate to instead of using allocated count, I guess I don't remember why. Okay, vector settings request. All right. Um, let's ask me first. So we want the scan forward 64. Page. Okay. So this is a little weird because it's this function uses a 1-based index rather than a 0-based index, which is kind of awkward, but it lets them use an unsigned return. So what's going on here? What is the actual return value? Okay. So this will find the first bit that is set in this 64-bit integer, starting from the least significant bit and going to the most significant bit. It's the forward part of it. We actually don't want that. What we want is, again, we want to find the first unset bit. So we will invert this. Again, this is something that we get, those are just your deciding decisions to make about your allocators, whether you can start with free objects are set bits and you scan for a free set by just scanning for a set bit other than an unset bit. It doesn't really matter. You can, like, it's an extra instruction per word in this vector, but ultimately I don't think it's going to be that big of a deal for us. I just like the idea of bits are set for free things rather than others. So it sounds like this will turn non-zero if it finds something. Explicit here. So if we found the bit, this index is not actually our heap index for like 2 or 3 different reasons. First thing that is incorrect here is it's one-based index, because they need to keep 0 for the hey, you gave me an invalid return thing, which is a bit awkward. So I'm going to subtract off 1, and that will give us the actual index. Now, this is still not our actual thing, because there are some number of words deep into this set of bits, so we need to I times 64 plus an index within this word, and that gives us a global weight. Here's how far here's our bit offset to the start of this vector. So when we get that, we also need to actually set the bit on this word so that nothing else can come along and try to allocate it again, right? So actually, order here, I mean, we know it's 0, so that's what we'll do the same thing. Actually, no, actually, not do the same thing. So this will set the bit. And then we get to break because we're done with our search. So we can still run out of bits, and so we need to assert that we actually got the we got a reasonable bit. You know what? Just to shut this thing up, I'm going to go and use 64-bit heap index. This is also to be. Okay. Whatever. Right, this is actually not going to work because we have cases of allocating multiple bits. So this is actually going to be harder to do than we expected. Surprise, surprise. We kind of need our per frame thing to be separate from this. Let's say it requires contiguous allocations, whereas the rest of this doesn't necessarily. So. So like you could do this with a bit scan with like you scan divine the first 3 bit you can, then check the next n bits manually for does it match. If it doesn't, then you keep scanning, whatever. But that's complicated, and then you start getting into like fragmentation issues of, hey, I allocated this. Like I know that I have 10 descriptors free, but I can't find a place to put my block of 8 descriptors because the 10 are scattered all over the place. So we would probably have like 2 separate allocation functions. One for, hey, I'm doing a per, I'm doing multiple allocations that need to be contiguous, and another one that is just, hey, allocate a bunch of these, and I don't care if they're next to each other. So we can make this return multiple handles if we need to. But that refactoring will be a lot, and we've already gone quite long today. 3.5 hours. All right. So I'm going to go ahead and call it here. I might be back next weekend. I might actually be back earlier because I have half the week off because of Thanksgiving. And it's not like I'm going to do anything. So maybe we will get a Thanksgiving special stream or something. I don't know. But yeah, we are getting close. We are getting very close. At this point, I want to handle this allocation issue before we get into creating, general render targets and such, because it will come and bite us if we don't fix it. But we are very close at this point to being able to put together an actual frame that doesn't just render straight to the swapchain. And that's when all of this is going to get exciting. So, I hope you all will stick with me, and I will see you next time.